Welcome, AP Stat students. So I'm going to give you guys a little intro as to what we're doing here for the remainder of the year after the exam. So starting in June, what we're doing is I want to take you through credit score and a little bit of financial planning. It's going to be fast. There's not going to be a ton of assignments due. So as we go, as we learn a little material, we'll post a couple questions just to see if you've kind of understood the material. So real fast, before we get into the actual credit score, what I wanted to do was keep you in the same time frame as the intro to stat students. They're right now just being introduced to interest and how that impacts our finances. So interest is basically the cost for borrowing money or the earning when you loan money. So real fast, when we borrow money for a car loan or a house loan, the bank that funds the initial payment, they're basically trusting us to pay that money back. Now, for them to take the risk, because there is a risk of us not paying the loan back, they have to have some sort of reward that will kind of make up for it as an investment. So if they're going to loan us money, they have to make money off of that loan. And that's where interest comes in. Now, the reason it's tied to statistics is because there's a risk involved. There's always the chance that the person that you're loaning the money to, their financial situation changes. Okay. Some life things can happen. So there is, of course, some inherent risk that goes with that. Now, credit score gives the bank kind of a sense of, all right, let's say that their finances stay pretty steady. The credit score gives them an indicator of what's their likelihood of paying back this loan. So that's where it's going to come back to after we learn a little bit about interest. It's going to come back to that credit score impact. So there's a way to kind of predict what the risk is for each person as we lend them money. Now, what we're talking about here with interest is that's the reward that they stand to get. Okay, so I started out with a few really, really simple examples that I'll go through. $100 in a savings account. That's nothing, but I just use nice numbers so that we can start out with simple stuff here. If you earn 4% annual interest rate, now you'll see that as APR, annual percentage rate, when you look at loans. So 4% annual is what the expected return on this investment is. So when you put money in the bank, you're actually the investor. You're investing in the bank. They get to, move your money around and make some financial moves with it, and you're basically giving them your money for a time so that they can try to grow. You get paid for that. Your reward for leaving $100 in the savings account for a year is going to be $4. So we just use really super simple numbers, okay, to just give you a sense of that. Now, let's say that interest was compounded once a year. That's not realistic. That's not what happens. What happens is now when we have a 2-year investment, okay, and basically what you're saying is the implied situation here is you're not going to take any of that money out. Okay, you're going to leave that sit for 2 years. Compounded interest means the interest is going to be calculated at the end of the first year, which you see here. So you get $4 interest for the first year, and now you have a balance of $104. Now, if you don't take that $104 out, there's a little more there to earn interest on. So 4% of a little bit more is, instead of just $4, it's $4.16. Now, of course, that's not a lot of money. Okay, that's not a big difference. But what I want you to see is that as you leave money in, every time it's compounded, it does give you a little bit more than what people realize. Basically, to shortcut this, what I'm trying to teach you is that compounded interest will be an exponential function. Okay, so I'm going to click over to my graph here. Okay, what I want to show you here is a bigger example. Okay, this is an example I created for you guys so that you could see it. Let's say I invested $10,000 and I was going to get a 6% annual percentage rate of growth for that account. So 10,000 is invested, and then this is going to be the 6% annual interest. Now, what I want to teach you guys is that it's exponential function. Okay, the blue is what really happens with compounded interest. Okay, so X would be the number of years that this money stays in the investment. Okay, so what I did was I kind of give you a sense of, okay, let's say we move, or let's say we keep the money in this account, 6% annual interest or annual growth for 20 years. Okay, sorry, some things are in the way here. 20 is not going to be helpful. Okay, so how about if we go 30? For 30 years, that total investment that was $10,000 is now worth $57,000. Okay, so you could see that that's a significant increase in what we've earned. Okay, now let's say we were to go to what a lot of people think interest is, which is they think it's simple interest. They think that what happens is you just take that 10,000, which you don't. You don't just take the 10,000. Right here is what people think interest is. Simple interest is a linear function. That's not what happens in real life. Okay, in finances, we don't do simple interest, but simple interest would be a linear function. Notice X is next to the 0.06 and multiply. This is linear. Okay, what you've got is your y-intercept is 10,000, and then you have a growth of 0.06 per year. Okay, 0.06 times the number of years. So times the 10,000 on the 10,000. Okay, on that right there. All right. Now, exponential versus linear. The same time frame if we tried linear, okay, it would only be worth about 27,900. So you see that true compounded interest is significantly faster growth as you over time than simple interest would be. Okay, if you want more details on that, you'll just have to look up what's the difference between simple interest and compounded interest. All right, I'm trying to show you exponential growth for the true real life compounded interest. Okay, so let's go back over here. So showing you guys this. Let's say we invest $5,000 into an account that earns 6% annual interest rate and compounded annually. That means the interest is calculated once a year and then fed back into the balance, which is what the investment is worth at that point in time. Okay, so what happens is this: you have an initial investment of 5,000, right? After one full year, you apply a 6% growth to that $5,000. 6% of 5,000 is 300. Okay, now put that 300 into the account, and that's called your balance. And then the second year that it remains in there, you're going to apply this 6% again. Notice this time instead of 300, it was 318. Okay, so your growth is a little higher because your balance is a little higher that you're applying the percentage to. Okay, and then it goes to 355. Sorry, I didn't subtract right here. So it's like 330 something there, 337-ish is the growth that year. So each year, what happens is your interest earned is even higher than the previous year. Okay. Now, simple interest, every year you'd gain $300. That's it. So it'd be 5,300, 5,600, 5,900. So if you notice, compounded interest is starting to give us an advantage. Okay, the next one would be 62, then 65. Notice that you're really starting to get ahead here with this compounded interest setup. Okay, so down to the 10th year, all right, really it should only be worth $8,000. You should have gained $3,000 if it were simple interest. Because it was compounded, which is exponential growth, you actually earned, instead of just 3,000, 3,954. And that's just after 10 years. So it's a $954 advantage by compounding the interest rather than just simple interest. Okay. That continues as you get further and further in time, 20 years, 40 years, things like that. Okay. So that's taking you through this assignment that I left you with, just compounded interest, short version of it right there. Okay. So what does interest have to do with statistics? All right, what I want to teach you is, again, what I mentioned before is interest is part of lending and borrowing. Someday you're going to buy a car. You might be able to pay for that car in cash, which means all of it up front. You don't finance or borrow any money to get it. In that case, interest is not involved, and neither is credit score. Okay, what I'm assuming here is that at some point you're going to need a loan to buy a car, to buy a house, things like that. So what we want to do is we want to teach you a little bit about that. So the interest is tacked on, as a reward for the lender or as a cost for the borrower. That's basically how it works. So we got to understand interest to understand, real life finances. All right, a credit score is a lender's way of measuring the likelihood of a borrower to pay back a loan, okay, with the intended interest and on time. Okay, on time is big because if you make late payments, technically you're borrowing the money longer, and you have to, there's fees because the payment, the money was borrowed longer. You can't just freely borrow money longer from lenders. You have to pay what you're expected on time and everything. So. Now, this is a risk-reward model that can be created by lenders. All right, that's what loan officers do. They measure your risk of paying back the loan, and then they also consider what's their potential reward if you do pay back the loan on time. And then they decide is that really a good, transaction for them to invest in. Okay. Something simple that we all really should know before we move on with interest is there's this old rule of 72. Okay, your parents probably heard about it. It was very popular 20 years ago to talk about the rule of 72. So quick, if you want to have an intelligent conversation with your parents, you really should know what this is. Basically, what you have in a compounded interest situation, which is real life finances again, basically, if you multiply the interest rate that you're expected to get, or the annual growth of something, if you multiply that rate by the number of years, if that product is 72, then your investment should be doubled. Okay, it's hard to understand that without a couple examples. So here goes. Let's say Brian invests $10,000 into some account. Okay, now he expects 6% annual growth on that investment every year. Every year. Okay, it's going to increase by 6%. And remember, this is compounded. So 6 times 12 is 72. So Brian can expect that in 12 years, his total investment will be worth $20,000. That's really how the rule of 72 works. 6 times 12 is 72. So the percent growth times the time. If that's 72, you can expect your investment to double. Now, it's just close. It's an approximation. But it's if your parents ever say, did you learn the rule of 72? If you haven't, if you start talking finances with somebody and you don't know the rule of 72, they're just going to shut down. They're not going to listen to you. Okay, they're going to know that you really don't understand a really basic concept. Okay, all right. So second example, if somebody invests $7,000 and expects 8% annual growth, what we have is we would expect 9 years for that $7,000 to double, because 8 times 9 is 72. Okay, so that's when we would expect the total investment to be worth 14,000. Okay, so they would have gained 7,000 worth of growth. So 7,000 original, gain 7,000, total value 14,000. Okay, we don't expect them to gain 14. We expect them to actually just double their money. Okay, so there's that. All right, so real quick with this one, if we invest 5 and we expect $5,000 and expect this to be our annual growth, how many years before we can expect this to be worth 10,000? That means double. Okay, so the 5,000 turns into 10. Using the rule of 72, well, 7.2 times 10 will get us 72. So the answer to this one should be 10 years. All right, watch out for this one. Okay, you have 4,000, 9% growth annually, and you want the investment, you want to wait till it's $16,000. Well, that means it's doubled twice. So 4,000 doubled is 8,000, 8,000 doubled is 16,000. To double twice, we have to hit 72 twice. Okay, so 9 times 8, 8 years would get us 1 doubling. Okay, this is a little strange, a little tricky. So we double once in 8 years, but we got to double it again, so that's another 8 years, 16. Okay. All right, just talks about why you learn it. We'll go through, you can read that. I don't need to go through that stuff. Back to interest. Okay, interest as a borrower is a little bit different. All right, now here's how this works. You're going to buy a car. You've got to pay the car back in full in the time allowed. Okay, so you're going to, at some point in your life, probably buy a car if you have to get what's called financing or borrow money to get there. Usually there's an interest rate. Now, 0% is kind of an incentive lately. Don't expect that. In most cases, there's going to be some interest kind of penalty or cost added. But to keep it simple, let's start out with what would your payment be if you bought a used car, say for $8,100, and there was no interest attached to it. Now, there's a certain amount of time you have to pay your loans back. Okay, very common right now is 5 to 6 years. Okay, that's the majority of them. Some of them are 4. Okay, so just depends on what you get into. But let's say it's 5 years. What really is going to happen is it's going to turn into 60 months. Okay, payments are per month, so know that 5 years converts to 60 months real quickly in your head. If there's no interest, you're going to just take the amount you finance, so the principal of the loan, $8,100 divided by 60. That means $135 of payment. Not bad. Okay, so that's what you should expect to pay for 5 years. All right, next one. What would happen on if you borrowed $7,200 and you had to pay it back in 4 years? So what would you do? Make sure that you do 7,200 divided by 48. 48 months is how many is 4 years. So that would be $150. That's at 0% 0% interest. All right, that's not realistic, but at least you know how that works. What's really going to happen is there's also going to be interest attached to these loans. That's going to increase how much you have to pay to get the payment completed in the time allowed, that 4 years, okay, for the life of the loan. So here's how this one works. So in reality, you're probably going to pay some kind of interest. You know, if you've got great credit, you might get as low as 3.5% right now, 4% maybe. But, you know, not many people at a young age will have good credit. So let's estimate 6%. That would still be a solid credit or interest rate, you know, for whatever your credit score might be. Now, what's going to happen is the 135 is not going to be enough to cover the cost, the principal of the loan, plus the interest. Okay. In fact, what will happen is there is a way to calculate the payment that'll be for another time. Let's just say you had that calculator. You can type it in on pretty much any app. The phone will, calculate your payments quickly. So $156.60 is what it would really cost, which is weird. Okay, that's about $21 a month higher than what we should have to pay. Well, that's because of interest. Now, let's see. What I want you to understand is how much extra you have to pay for the loan if you pay the exact minimum payment on time the whole time. So if you pay $156.60 for 60 payments, that's $9,396. The original loan was for $8,100. So you've got to pay an extra, look at $1,296. That is the cost of not having the money up front or borrowing the money. Okay, so $1,200 extra, $1,296 in fact. So when you realize that, it's a little bit of a shock. Okay, so wait a minute, I got to pay more because I don't have the money to pay for it all up front. And the answer is yes. So you have a choice. You either save up and never borrow money, or just understand that that's part of the cost of borrowing money. Okay, so you can read through that, same thing. Okay, basically, here's what we're looking at 11 is why is this so much higher than the previous example? $273.64 is the payment that's going to be needed for this next one. So two things. First, how much you borrowed was much higher. It was $8,100. The previous example, this one's $12,000. It's a lot more. Okay, the more you borrow, the greater the interest impact is. Now, the interest rate went down. Okay, so that's good. Okay, 4.5% lower than 6%. And it's only for 4 years. So because the time is so much shorter and the amount borrowed is higher, what you're going to have to do is you're going to have to pay bigger payments. So watch that. If you can't afford the bigger payments, you have two choices: buy a cheaper car or take the car loan out for longer. Neither option's great, but you've got to figure out what works for your finances. Okay. So what you're going to do now is get a sense of how much extra that is. Okay. So how much interest is there in the life of that loan? Okay. So what I'm going to do right now is calculate what is $273.64 times, not 12. It is 48. So we should multiply by 48. 48 months. Okay, so that's going to be $13,134.72. Now, what's happening there is now it's going to be $1,134 extra for that loan. Why was this one $1,296? Well, two things: higher interest rate and a longer amount of time borrowed. Okay, even though this is a greater amount, you're borrowing it for a shorter amount of time and a lower interest rate. So this is going to be an extra $1,134.72. Okay, so to understand interest payments, a lot of people miss this. They don't realize what's going on. The interest is applied to the full balance that is owed on. The balance is what's owed. I don't call it principal because the balance diminishes every time you make a payment, right? So the balance at month 0 is the principal of the loan. You borrow $12,000. Okay. After the first month, what happens is they penalize you, or there's a cost for borrowing that $12,000 for that month. It's 4.5%. But it's not, you didn't borrow for a full year, you only borrowed it for a month. So they do factor that in. Okay, so 0.45 divided by 12, multiply that by the amount you borrowed, and that gives you an extra $45 of interest. Now, you had to pay $273.64. All right, here's what happened with that. This $273.64 covers the interest by a lot. Okay, plus it chips away at the balance. So that after the course of 48 months, the balance is completely paid off with the interest as well. But the interest is added, before the payment is made. Okay. So the new balance is down to 11,771. It was 12,000. After one payment, it came down, $229 or $228 and some change. Now wait a minute, you paid 273. Why did it only come down 228? That's because 45 of that is, had to pay for the interest first. Okay. Now the next month there's less interest added. Okay. So the 45 comes down a little bit. Okay. Every month there's a little less interest because it's a smaller balance. Interest is only applied to the balance. Now you make a payment and it comes down even more. The balance comes down even more. So the highest amount of interest you pay is the first month, and then the interest slowly diminishes. This is different than what the first examples were with the investments, because remember, we're paying some of it off, okay, as we go. So that balance is coming down. When we did investments, the balance never diminished. It actually grew as we earned interest. Okay, so you go ahead and read this and look into it a little bit. So that's pretty much going to take you through that. So here's, okay, number 15. Is it true that a higher credit score, the lowest interest rates paid for borrowing? The answer is yes. So that's where we're going to swing back over to credit score here in next week's topics. Okay, so I had to give you a sense of interest first. Then I could take you back to credit score. Better credit scores get you a lower interest rate, get you better options because you're less of a risk if you have a better credit score. So your cost of borrowing money is going to be lower. All right, hopefully that'll help you get started with why we are studying interest and where we're headed with the rest of the course. Look forward to, working with you and hopefully getting you ready to get out in the real world. Take care.